Hi, and in this short video I'm actually going to measure peracetic acid. So peracetic acid or peroxyacetic acid. I do have the hardware in front of me. I've also got a couple of precursors for this. I've got hydrogen peroxide and I've also got acetic acid. So I'll mix those up shortly. I'm actually going to end up doing sort of proving the assay, let's say, in a real sample. I happen to be using milk. The nice thing about milk is it's a real world sample. It's not a synthetic sample in terms of just buffer, which is just pH and salt. There's lots of different interferences and materials in milk, so it's not a bad thing to sort of prove out an assay in. So that said, I'm going to prepare the peracetic acid. Also going to then sort of prove the principles of an assay using actual milk. So just watching for that. Just a couple of slides just to kind of try and introduce the science a bit more. So as I say, this will be about peracetic acid or peroxyacetic acid or PAA, as it's often called, at least online. Not that it really matters, but it's an acetic acid with a kind of a peroxy group instead of what we sometimes call an OH group. I will be mixing together a couple of solutions, one of acetic acid, one of hydrogen peroxide. I'll be creating quite a stock solution of that, but I'll be very quickly diluting it, and then I'll actually, when I probably end up in the end sort of showing you the signal for about 20 ppm, but you'll even see that the signal for 20 ppm is actually quite intense. So when I say ppm, I mean parts per million of the PAA, the peracetic acid. So I've got the word demo. This is just to remind me to sort of go ahead. So I'll do a I'm going to prepare things first of all. So what I'll do is I'm just going to grab a quick tube. I'm just going to grab a pipette. If you see me reaching behind me, it's just to get pipette tips. So I've got a pipette tip here, and I will be taking 100 microliters of the hydrogen peroxide, which I will do. I'll put it in the tube. So I've done that. I'm just going to get 200 microliters of the hydrogen peroxide. No, in fact it's not. It's 200 microliters of the acetic acid rather. So let me just grab that. So 200 microliters of the acetic acid. 1 and 2. So I've mixed those together. So I've approximately got them in the right ratio in terms of molecular ratios, that is. So I think when people are using this, because PAA is not necessarily super stable, I think it maybe in part its kind of sterilization properties, its disinfectant properties possibly come from the fact that it is quite reactive. It's quite a strong oxidizer. So I've mixed those two materials together. What I'm going to now do, now that effectively forms me about 21,200 ppm of that solution. What I'm going to do is I'm going to grab 100 microliters of that solution. It's hard to keep track of all the things that are going on in front of me, but what I'll do is I'm going to grab 100 microliters of that, because don't forget this is very concentrated now. So I've just formed essentially the reagent in real time in front of you. I'll grab 100 microliters of that. I'll put it into a new tube, which I've just done. What I'm going to do is I'm just going to put sort of the tubes out of the way, otherwise when one will end up grabbing the wrong kind of tubes. What I'm going to do is I'm going to do an approximate 1 in 10 dilution with that. I'm just going to grab some milk. It's a complex sample. It's fairly representative of the complexity of the real world. I even think that PAA, peracetic acid, is actually used in probably washing down equipment that's been in contact with milk. So I've got that kind of mixture together here. Now what I'm going to do now is, I'm going to go to the kind of experiment itself. So what I'll do is, I'm thinking aloud a little bit. I'm going to take milk that has not had PAA added to it. And I will, first of all, what I'm going to do is, I'm using the SenseItAll platform. I know I didn't absolutely do a big introduction on that. And I suppose as I do this, I should say the SenseItAll platform is a way of going from an idea to a tangible piece of hardware. In the right applications, you could even say a minimally viable product really quickly. One of the big problems I would say in biosensing electrochemical assay development is people spend a lot of time reinventing the wheel. We've built a platform that independent developers can essentially come upon and start developing their own assay. So what I'm going to do is I'm going to take pristine milk, i.e. the one that I've not added any PAA to, and I'm just going to put 50 microliters onto it, which I am doing here. And I'll kind of get myself a little bit ready, because what I'm going to do is I'm going to start an experiment, and then to kind of demonstrate how, that we generally have a signal for the peracetic acid in this particular assay. I'm then going to just add a tiny amount of now this, what I'm spiking with here is at this point it was 21,000 approximately ppm, but I did a 1 in 100, sorry, I did a 1 in 10 dilution, which would have brought it down to more like 2,000 or 2,100 ppm. But in fact, what I'm going to end up doing is spiking this and probably bringing it to more like 20 ppm. I'm actually going to do quite a high dilution on this. So let me start the experiment. So it's running along now. You'll see the data appear on my phone in real time shortly. Right, so I'll try and go through the maths quite quickly. So I prepared a solution of about 21,000 ppm. I did an immediate 1 in 10 dilution on it, which I did here. I then, I've just put a fresh solution of milk on there that's got no PAA in there. I'm going to just add in a tiny drop of milk here, and I'm probably going to do a 1 in 100 dilution. And I shouldn't miss my, so what I'll do is I'll just do a drop, really just, I'm just going to touch it. There we go. Right, now what I should have done actually is get ready to actually mix this. So before it runs out of time, I'm just going to mix that in a little bit now. And you can see that jump up like that. And that's because, in fact, now I've just made sure that the PAA has actually got throughout the entire milk. When it comes to the end, so you can see my signal before the PAA, you can see my signal after the PAA. It's about 20 ppm in there. It's quite an intense signal. So the reason I did it at 20 ppm is because people are kind of interested in that range of sort of 0 to 2,000 ppm. So I essentially did it near the lower end of the range. Now at this point it says upload complete. So what I'm going to do is I'm just going to navigate to here, and I'm just going to show you something. Because when it says upload complete, the really beautiful thing about this system from ZP is it sends data to the cloud in real time. So I've got the data up here, and once I go in here, we can have a quick look at that raw signal. So ZP definitely has a kind of sensor to cloud. So what's going on here is that peak height there really is a response to approximately, if I had 20 ppm in there, then that's what the kind of signal intensity would have actually looked like. But what I can now do, see, is I can kind of very quickly go from, oh, well, that's raw signal, that's not much use to me. But that's the point. This is what the ZP SenseItAll platform is so good at doing. I can come in here, I can show extracted value. I'll look at the peak height. I'll put in about 50 seconds here. I just want to have a quick look to see what that's done. We've got a very powerful back end here that we can grab electrochemical data, automatically send it to the cloud, and process it in the cloud. So I can see here that I've got the peak height, but now I want to give it the right unit. So imagine now I'm the kind of scientist in the lab starting to really develop this assay. And actually we can go to that kind of assay really quite quickly. I'll give it the right units, parts per million. So I've changed the units there. I just want to change the, let me just try something out here, 0.0. I'll put 0 here. And I just want to have a quick look at the ppms, what they look like at the moment. Yeah, not too bad. So I can see now that I can start this is how I can very quickly get from the idea of raw signal to a real concentration, just, without, I didn't code, I didn't spend hours doing it. So I would like to summarize a sort of situation like this. So what I've done is this: I've taken a source of hydrogen peroxide and a source of acetic acid, and I've mixed them. Now, admittedly, they say you have to wait 15 minutes. I think the real answer is it's probably quite fast, but people don't really know what the kinetics are like. But I mixed them, and then I created essentially a spiking solution in the milk. But then I actually put raw milk without any PAA onto the sensor, which you saw me do, and then after about 40 seconds, then I added in just a tiny amount of this spiking solution, just to kind of show you that I generally can make an assay for PAA quite quickly. And that assay, we were probably getting down to about 20 ppm. But even at 20 ppm, I would super argue that the signal is actually quite intense. So, with the right kind of scientific effort, then it wouldn't be any problems. Going up is easy. Coming down, you can still see there's quite an intense signal there. So those of you who have a scientific and engineering mind can understand that that's quite a lot of signal, and we can just do fractions of that and still have a decent signal. But you can see then that I was actually able to, using the power of the Julie backend database, actually able to go from just peak height or signal strength to actual ppms really quickly. And then once that's done, we can actually create a new QR code, and it becomes essentially its own live assay. Now, if you do have any questions regarding SenseItAll and our ability to develop assays for analytes like PAA, peracetic acid, I would say don't hesitate to reach out to us. Okay, thanks very much.